Welcome everyone to the webinar. There's quite a few of them, so I will start. Well, as you may know, my name is Madeline Pryor. I am the moderator today, and welcome to Printing with Polypropylene Pellets, Benefits and Applications. I would like to quickly introduce you to our panelists, Eva Garcia-Biosca, Dr. Tony Ivora, and Gianluca Pugliese. If you could just say hello.
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 Everyone. Good morning.
I will introduce everyone a little bit later, but while everyone is still trickling in, I actually just wanted to share a poll with you all. It should be on your screens now. So if you could just take a couple of moments to fill that in. It's just to get an idea of who you are, so we know what to expect for the webinar. I will leave that up right now. Everyone should be able to vote. So just to let you know as well, we will be recording the session today. When and if the session will be available, we will let you know. We just need to do a couple of things beforehand, but we are recording it. Don't worry if you're an attendee, you are not on the screen. I often get that question. So another thing, if you will note, at the bottom of the screen, you'll see something that says Q&A. This is the Q&A button. If you have a question, please do ask it in that section, because otherwise we will not necessarily see it. If you ask it in that section, then we will be able to access it. And there we go. You can probably see it now. You can see everything. I'm just going to wait for a couple more people. Perfect. I noticed that it turns out we're not having sound problems, so that is good. And we will get started in a moment. So if you could just move to the next slide, please. So as you can see, this is the agenda for the next hour or so. The first is this introduction, where we are now, before we were moving into 3D printing materials for pellet 3D printing and their benefits, as well as a bit of an explanation about what pellet 3D printing is, and then the case studies and success stories with polypropylene in general. The final 15 minutes will be the Q&A. So again, if you have any questions, please do ask it in the bottom. You will be able as well to vote on questions that you might like as well. If we could move to the next. So here are panelists for today. As you know, well, as I mentioned, my name is Madeline Pryor. I am the English content specialist for 3D Natives, the largest international online media platform on 3D printing, which is available in 5 languages, actually, English, as you might have guessed, but also French, German, Spanish, and Italian. As I previously mentioned, I will be moderating, so I will be doing this introduction as well as the Q&A at the end. You can ask any of your questions below. So moving on to the panelists, first up is Eva Garcia-Biosca. She is an advisor engineer at Repsol. She graduated with a degree in chemical engineering from the Instituto Químico de Sarriá of Barcelona. I apologize for butchering the Spanish language, and has more than 20 years of experience in research and development projects in Repsol. Notably, her fields of expertise include polymer processes and optimization, innovation, and new product development. Next, we have Dr. Tony Ivora, who graduated with a degree in chemistry from the University of Valencia, and has also stayed in the University of Manchester and Pontificia Catholic University of Argentina. He holds an MBA in International Finance and Investments from the University of North Carolina, and began his research career at the University of Southampton, where he obtained his PhD in chemistry for his research based on materials with photocatalytic properties, and where he also carried out teaching activities. He has presented his work at national and international congresses, as well as in peer-reviewed published articles in first quartile scientific journals. He is currently a lecturer at the Francisco de Vitoria University and a professor in chemistry at Florida State University, teaching chemistry 1 and 2, as well as experimental lab. Since 2021, he has led the commercial strategy and positioning of the Nova Spider project at IT3D Group. Last, but certainly not least, we have Gianluca Pugliese, who is a specialist in 3D printing. In 2018, he founded Lowpoly, which in Madrid, I also am just ending the poll. And I'm showing the results as well, so you can see that. But he founded Lowpoly in 2018, a company that is dedicated to sustainability in the field of large format 3D printing, researching and developing new technologies and sustainable materials. He specializes in retail, decoration, and interior designing projects for various international brands. Additionally, he is a teacher of 3D printing and digital craft at IED Madrid, LCI Barcelona, and IE Business School. In 2014, he exhibited at the Venice Biennial. In 2018, he was a consultant for UNESCO Mexico, and in 2020, he co-authored with Diego Cuevas the book Advanced 3D Printing with Grasshopper. He is also, since 2019, the Italian Design Ambassador. So we have some really great experts with us today, and they'll be sharing with us some really cool things, so stay tuned. Also, I just wanted to share, so as you can see on the screen, we have the results. Most of you have 3D printers, but are working with FDM. This will be very interesting for you. As you'll see, FGF is similar to FDM, except it skips a couple of steps, notably the filament stage, which makes it a lot easier. And many of you want to use polypropylene but haven't tested, so you are definitely in the right place. So if we could just move on to the next slide. So just quickly, for those of you who don't know, you probably saw it in the beginning, but today we'll be talking about fused granular fabrication, which is also known as pellet 3D printing. I just wanted to tell you quickly what it was. It's essentially where you have FDM, it's extrusion, except you use plastic granules, plastic pellets, which are melted and fed through a nozzle. It is incredibly popular because of its cheapness and the ability to use a wider array of materials, especially as compared to traditional FDM and FFF. And actually, if you see in the graph below, where we are really interested in it today will be with polypropylene, or PP. And currently, polypropylene is actually is one of the most used materials in industry, but it has been slow to adopt in AM. You can actually see it's mostly used in other methods. That's what the graph is showing, but with FGF, that is no longer an issue. If we could move to the next slide. So as I mentioned, polypropylene is the most used polymer. It's used in a lot of objects that you've probably already heard of, but it has been slow to adopt in AM because of difficulties in printing it. With pellets, it's not even only cheaper, but it's easier to print, and that is what we'll be discussing today, how to do so, as well as what its benefits are and the various applications. Hearing especially from, well, our 3 experts who work directly with this material and who work with pellet 3D printing. Next slide, please. And then just to show you, the demand for PP is definitely there. As you can see, it's used in a variety of things, including automotive and packaging, especially in Europe, which I believe many of you come from, though not all of you. And so that is why we are interested so much in this topic at this point of time. So that is actually it for me. I will now turn it over to the hands of my very capable experts, starting off with Eva Garcia. Take it away, Eva.
Good morning to everyone, and thank you, Madeleine, for your nice introductions. As you said, today we will talk about printing with polypropylene pellets, benefits and applications. Next, please. Yeah, just an overview of Repsol, what we are, what Repsol is, why is propylene a appealing material for 3D printing, and especially for granular 3D printing. Then we will talk about benefits and applications, and we give some tricks on how to print with polypropylene and an overview of developments and trends. Next, please. Yes, Repsol is a global multi-energy company leading the energy transition with its ambition of achieving zero net emissions by 2050. And Repsol has a chemical division, Repsol Química, and produces mainly, among other products, polyolefins. If we talk about polyolefins, they can be divided in 5 families: high-density polyethylene, that is present in packaging or pipes, for example, low density polyethylene that is present in cables on pharmaceutical blisters, for example, metallocene films with polyethylene that are devoted most for food packaging, but also for industrial, and ABA and EVA polymers that are most found on hot melts and sport shoes. These are families that belong to the polyethylene family, but if we focus on polypropylene, polypropylene is widely used in industry, as we will see after. And as an example, it's used in furniture, in decorative, in household appliances, in automotive, even in exterior and interior, is used in packaging, in fibers, cables also, pipes, and a lot of appliances. So this is the reason we think polypropylene has a role to play in 3D printing. You can go to next, please.
This meeting is being recorded.
Why? Well, the reason we think polypropylene has a role to play in 3D printing is because, in fact, it's the most consumed polymer in industry, with a 19% of consumption. But if you look at the polyolefins that are the third last materials in the graph, is among the 50% of the polymer used in industry are polyolefin. So there is a big opportunity in using polyolefins because it allows to open a lot of different applications, including packaging, building and construction, mobility, healthcare, among others. So you can go to the next, please. The question we faced some years ago is why, if polyolefins and especially polypropylene is one of the most consumed material in industry for real applications, is not yet widely introduced in 3D printing. Even though polypropylene has huge benefits because polypropylene is highly stable, chemically stable material. It can support most of acids and bases and solvents. Also, is a quite light material that can give you up to 20% of additional weight reduction. This is compared with PLA or PETG because it's less dense. So this is especially important in automotive, but also is important is a way to save money because your piece you will need 20% less material to build your piece. So it's a huge opportunity there. Also, it's a material that has a high flowability and good processability, but and gives you really nice mechanical properties because it's a tough and impact resistant material. And last but not least is 100% recyclable material. So if is it a nice material, why is not widely used? Well, it's true that polypropylene has some challenges to face to be printed correctly. The main problems you can face when you print with polypropylene is the addition between the base and first layer, and also the addition between layers. And warpage, if your warpage is just the tendency to shrink when the material gets cold. So for not all the polypropylenes you find on the market are good polypropylenes to be printed. There is need of special grades, especially designed for 3D printing, that will give you the best performance. So that was the reason we started some years ago working on polypropylene, especially designed for 3D printing. We can go to the next, please. Nowadays, we have 5 different polypropylenes, grades of polypropylenes, especially designed for 3D printing. the materials are in granule form, and they can be used directly as a raw material for granule printing, but also as a raw material for filament production and FDM filament uses. So one of our grades, for example, is available by the trade Recreos with a partnership with Recreos. And talking about the different polypropylenes, you have to think that we have, for example, for the main portfolio of polypropylene is about 300 different degrees that are devoted for extrusion, injection, film production, and each grade is designed especially to have the properties that the final application will demand. So here we have 5 products. 2 of them, there are compound products with mineral fillet and with glass fiber. The other 3 are neat polypropylene products devoted for different applications. They have excellent mechanical properties that allows you to build prototypes and also functional pieces. And one important thing is there are food contact approved grades and also skin certified grades that allows you to build medical application, medical tools, orthoses, and also polypropylene is a material that can be sterilized. So it's really suitable product for medical application and also is recyclable. Today we will focus on extrusion of pellets, but it's true that there are other technologies that can use polypropylene as selective laser sintering. And then we are developing 2 products on polypropylene powder that we hope will be available on the market soon. So next, please. Just a bit look of the difference between the products on polypropylene. You can have flexural modulus that goes to 800 to 6,200. If we talk on 30% glass fiber, that gives a wide range of applications. If we talk about glass fiber, for example, when you print the glass with glass fiber, and I think it's not only for polypropylene, this is a general advice, things that you have to take in account is you will need special nozzles that can hold glass fiber, because glass fiber is a quite abrasive material. Also, when you print with fibers or compounds that had fibers in it, we recommend a nozzle bigger than 0.6 millimeters to avoid to have jam problems on the extrusion. That are only general tips, but will help to be successful on the printing. You can go to the next, please. Here we will give some tips or general recommendations when you try to print with polypropylene. The printing temperature is between 100 and 240 degrees centigrade. And it's true that you will need to adjust the temperature depending on your printer, because it will be right if you have a laptop printer or a big robot. So when you start with a new material, there is the printing temperature is something you have to optimize. Also, we recommend if your printer can work with temperatures between 55 and 95 are good for polypropylene. In general, as a rule of thumb, any strategy you can take to cool the material slowly will help to be successful. Also, if you have a layer fan in your printer, we recommend to use it. As one of the main aspects to be successful is to achieve a good addition between the first layers and the base of your printer. we recommend, if you are able to use a brim or a rough structure to allow you to have a bigger surface of contact. Also, a primer or an adhesive is recommended. If you work with a laptop and it's the first time you work with polypropylene, one easy trick you can try is to use Pippy Tapes. They are quite available on the market. For domestic is good, so you can taste it. There are different, and depends on the composition of the Pippy tape, they will work better, because not all the tapes are made from PP. PP in general, polypropylene in general, stick really well with polypropylene surface. So Pippy tape is a nice option when you start. Also, there are sheets or films that are available on the market, especially designed for polypropylene, and they work well. There are also primers or adhesives on the market, and we can recommend some of them that work quite well. If your printer is a robot or a big printer, some of these strategies cannot be taken, but there are other options like use a corrugated plate or a perforated plate, or also wood, and staple your piece at the base. There are strategies that work well. And the last two, regarding the speed, you have to adjust the speed of your printer depending on the size of your printer, of course. But one thing that we recommend is to slow down the first layers. So you allow the first layers to be built correctly, and then you can speed up your printing and optimize your parameters. So we can go through the next, please. Now we want to talk about future developments and trends, and we divided the developments and trends into areas. One is regarding the improve the actual materials and the printing profiles and betadation that are more supporting or developments. But regarding trends, for example, we see a nice trend on developing non-flammable products, most of them devoted to building and construction and also mobility, like trains or aerospace, that will need non-flammable products, and there for special requirements we develop non-flammable products. Also, in the other side of the products, we see a nice trend in developing translucent and optical improved materials that are developed most for aesthetical purposes or decoration. And the last but not the least, I will remark is recyclable products. Recyclability in 3D printing is a huge trend, and you can obtain recyclable products in two different ways. One is mechanical recycling, that is mixing a post-consume recycled product with a virgin one and have a new product that has in it a percentage of recycled products. That is a nice way to have a recyclable product, but has limitations regarding the mechanical properties, because when you introduce a recycled stream on your product, sometimes you lose some mechanicals. So it's a balance between properties and recyclability then. The other way to achieve 100% recyclable product is by chemically recycling. That means you get a post-consume stream of polymer. You submit in a chemical process to a cracking, you obtain an oil, and you introduce this oil on the refinery. and you produce a new 100% polypropylene that is has the same properties as one. So, but it proceeds from a recycled stream. So we call that this is chemically recycled products. As a trend, other trend that is important in 3D printing and in general in polymers is bio-based. And we also produce bio-based polyolefins for 3D printing. So just next, please. As main takeaways, why we use polypropylene? Because it's the most consumed polymer and has versatile properties and opens a wide range of opportunities. And due to his good mechanical properties, you can build prototypes and also functional pieces. It could be sterilized, food contact, and skin contact. So it's a nice opportunity there for medical or food. And to use polypropylene is no need to additional machine investments. So only to printing setting adjustments. And it's a curve of learn that is easy to take, really. To keep in mind, polypropylene, only designed polypropylenes will provide the best performance. Not all the polypropylene you find on the market is good to be printed, to be 3D printed. Also, as I mentioned, food contact and skin contact, recyclability as a big trend, and we can supply, for example, for circularity, chemically recycled 100% from costume waste materials. So nice for me is everything, and I will let the floor to Tony Ivora. Please, Tony.
Thank you, Eva. First of all, thank you, Madeleine, for your kind introduction, and thank you also, Eva, from Repsol for the invitation to this webinar. Well, as you know, at Tomaker, we are committed to searching for strategic partners that allow us to build bridges between the screw extrusion technology that we commercialize and materials in form of pellets, as in this case, polypropylene. So in this context, I recognize that it's a pleasure to collaborate and to work with Repsol. So today I will be talking about the benefits of using pellet materials in the 3D printing world and our experience also using Repsol's polypropylene. As you know, traditionally 3D printing has made use of filamented materials. So this is a trend that we are seeing now that is changing. The problem is that the current 3D printing world is limited to those materials that exist in filament format. So this might be an impediment when it comes to the development and growth of the use of 3D printers or the pellet extrusion. So at Tomaker, we have decided to go back to the origin, to pellets, which are the initial raw materials from which all filaments are manufactured. So if we can go next, please. So the main benefit, the first benefit, can we go next, please? So yeah, as I was talking, the main benefit is that usually when we're talking about filament 3D printing, the amount of material that is required is frequently rather small. So due to the significant cost that will be involved, many polymers used in the industry are not filamented. However, now we are able to work with a variety of materials in the pellet form thanks to the pellet extruder or pellet printers. We can go next, please. Another advantage of using the pellet extrusion directly compared to filament is that pellet feedstock allows for a much higher deposition rate, and consequently we can obtain bigger prints and bigger parts in shorter times. However, it's true that as build rate increases, the ability to achieve a desired geometry and surface resolution decreases. Okay, so this is one of the main disadvantages of pellet printing, that we at this point, at least at Tomaker, we are not able to use 0.2 millimeter nozzles. Okay, however, we have large nozzles. Okay, so with large deposition nozzles, large beds of materials are extruded, per unit of time, allowing for more material output from the extruder and obviously increasing the build rate, okay? So if we can go next, please. Here you can see that we can start from 0.5 millimeters diameter nozzles up to 5 millimeters diameter nozzles. When we do the deep validation of materials, in this case, materials, polypropylenes from Repsol, we validate every single nozzle. As Eva was saying in her talk, when we use polymers that they have additives, glass fibers, mineral fillers, we try to avoid 0.4 millimeters nozzles or 0.6. We can start from 0.8. However, it is true that we were able to extrude and to obtain final pieces even using the 0.6 millimeters diameter nozzle. Next, please. One of the advantages also of the pellet 3D printing is the lower printing cost. We know that both filament and pellet 3D printing thermoplastics start out as granules, pellets. So filament materials are made by heating the pellets and forming them into a filament. So if we use pellets, we skip this step. So we avoid one heating cycle, which potentially means that the pellet thermoplastic will process easier, they will perform better, and they obviously will cost better comparable to filaments. Next, please. Another thing that we can do is using the pellet extrusion, we can obtain bigger prints because of the slower throughput and the higher resolution. Usually with filament printing, the parts tends to be used for smaller parts. However, if we use pellets, bigger parts are possible. And this is because we can use nozzles with bigger diameters. We can add also a robotic arm to the pellet extruder, so we are able to obtain bigger parts. And also, when we do filament 3D printing, we have to change the coil in most cases. If we use an automatic feeder, we are able to skip this part. We are able to have a continuous extrusion. In our case, we have an automatic feeder that has a capacity of 7 liters, and we are able to extrude polypropylene materials or any other thermoplastic into the pellet extruder in order to obtain bigger parts without worrying about filling the hooper every time. Next, please. Another advantage is the fact that we can use different materials. We can combine up to 4 different heads. This can be filaments, as Eva was also saying. Repsol is also commercializing filament, polypropylene as filament, but also the pellet. So we can combine in one piece different materials, different grades of polypropylenes. We can have, for example, one structure that contains an outer part of polypropylene with mineral filler in pellet form, and then we can print an inner part with filament, with same polypropylene or any other thermoplastic. This is something that we are trying now with Repsol materials, and it looks very promising. Next, please. Oh yeah, so another advantage here is sustainability. Eva was also putting attention into this part, and it is true because we know that currently a transition to a circular economy requires an adaptation of most of the industrial processes, and we are looking forward to do so. Okay, so we can reduce the fingerprint of most of the plastics because we can recycle them. If we can go to the next one. So in this context, what we can do is when we do 3D printing, if our print is not successful at the first time, we can shred them. We can shred that part in order to obtain flakes. Here in the example, you can see, in this case it's PLA, but this is also, we can extrapolate this to polypropylene. We can have a polypropylene part that was not very successful at the first time. We shred them, we obtain flakes, and then we do the 3D printing again, okay? So this is something that is highly important. It's getting trendy currently because, as I said before, we can reduce the carbon fingerprint and we can give a longest life to this kind of materials. If we can go next, please. Yeah, so what sectors benefit from using pellets? So we have the medical sector, as Eva was also mentioning, tissue engineering, we have drug delivery, we have energy storage, we have also certified sectors that they require materials that they need some kind of certification. We go next. And then we have railway, mechanical engineering, also prototyping, very interesting with the use of polypropylene, automotive, and aerospace. So in the case, if we go next, please. When talking about mechanical and prototyping, this field is very interesting for polypropylene, because the pellets that we have validated, including the polypropylenes from Repsol, include many performance grades designed to provide application-specific property profiles. So, for example, Repsol's polypropylene loaded with mineral filler combines an excellent impact resistance and processability. So this is very interesting, the fact that we can use materials that in some cases they are not filamented, and they provide specific applications and property profiles. If we go next, please, and then prototyping. Other fields that can benefit from the pellet technology, include prosthetics. I think Eva also mentioned this field. Making use, because as Eva was also saying, they are commercializing polypropylenes that they are approved, they are certified for skin contact. So we are having a lot of demand for prosthetics that they can use polypropylene because of the chemical properties and the physical, mechanical physical properties. And we are working to do so. We can obtain prosthetics that we can print using a 2 millimeters nozzle, 3 millimeters nozzles, only with one perimeter. So we reduce the printing time and we obtain solid structures. Yeah, so quickly, I also want to mention that the pellet extrusion is not limited. It's not limited to polypropylene, but we can also work with flexible and functionalized materials. We can work with thermoplastic elastomers. We can work also with high density polyethylenes and low density polyethylenes. We can also work with functionalized materials as the polypropylenes with glass fiber, with mineral fillers, and also other thermoplastics that they contain carbon fibers, hydroxyapatites, inorganic materials, also lithium compounds for energy storage. So the pellet extrusion is not limited. If we can go next. Yeah, quickly also mention before talking about the amazing polypropylene from Repsol that we are also able to work with metal and ceramic materials. We can use pellets that they contain additives, and then we can do the 3D printing. Then we can do a sintering process in order to obtain a metallic part and a ceramic part. This is something that we are also developing, and it looks very promising in the future. And our experience working with Repsol polypropylene, I have to say that it's been amazing. It's been really great. It's probably the best polypropylene that we have validated up to date because of the excellent processability. As Eva also said before, not all polypropylenes are designed for 3D printing. Actually, there are a very short amount of polypropylenes that they are designed for pellet printing. So it's very important to choose a specific brand, a specific material that has a chemical grade that is compatible with 3D printing. Okay, so our results show excellent processability, a very good stability of the printed structures. We have done 3D printing with 0.4, with 0.6, and different nozzle diameters with 1 perimeter and 2 perimeters. And now we are exploring this, trying to do multi-material parts using polypropylene Repsols, inorganic content, the mineral filler, and then another layer of normal conventional Repsol polypropylene in order to obtain multi-material parts, which we also find interesting. One of the I'm not gonna say disadvantage, I'm gonna say a challenge. One of the main challenges that we found is warping, which is associated to the use of polypropylene. However, we were able to significantly reduce the warping closing the chamber. Okay, so we close the chamber, we increase the temperature on the bed, and we are able to obtain a stable temperature of about 70 Celsius degrees, which in our case was successful enough to obtain parts with a good stability. Okay. As we typically do with polypropylene, we use brims in order to improve the adhesion of the first layer. We follow the guidelines that we got from Repsol. We reduce the printing temperature for the first layer in order to improve adhesion. Then we increase it. we use temperatures very similar. Actually, our pellet extruder contains two temperature controls, one at the upper part of the extruder and another one at the nozzle. Okay, so we set a temperature slightly higher than the melting point of the polypropylene near the nozzle, and then at the upper part we set a temperature near to the transition glass temperature of the material. This allows us to a very good flow, because at the beginning the material is not melting, it's actually softening. So we obtain a very consistent flow. Obviously, as we do with most of the materials, we did some drying in order to remove some partial humidity. So yeah, basically we can conclude that the Repsol materials, the polypropylenes, at this point are Tomaker approved, and we are very happy and we are able to recommend them with our technology. So well, that's all from my side. Thank you very much for attending the seminar. Appreciate it.
And now moving on to Gianluca, just if we can move to the next slide. Right.
Thank you, Repsol and 3D Native, to give me the opportunity to explain what we do in Lowpoly. As you can see, Lowpoly is a 3D printing company based in Spain that work on sustainable additive manufacturing. So we spent the last 5 years developing a workflow to recycle material or find waste and transform it in a new products. So next, please. As you can see in the slide, we use a large-scale 3D system between big 3D printers or robotic arms that we have here in Spain, and where we have a pellet extrusion system on it. Next, please. So the big goal for us is to find a way to transform waste in design. We was working with a lot of different kind of waste, from natural organic part with a commercial part, and like tires or bottles. We are developing also our system to transform the waste in a new material, in a new raw material, and we developed the ecosystem to reuse the robotic arm and repurpose it as a 3D printer for a large scale. Of course, in our case, is impossible to work with filament, because the scale that we afford is bigger, and is very difficult to have a good timing in production using a filament. Next, please. So more or less 1 year ago, we met with Repsol. It was a very interesting meeting. They explained us the idea to move the pellet granulate of polypropylene for 3D printing and large-scale 3D printing. So we was testing a lot of different grades, as Eva told before, and we found 3 different grades based with the mineral fiber, powder, glass fiber, and common polypropylene that we can use to 3D print. One of the important parts for us to using polypropylene, and polypropylene is not, in this case, is not recycled, but is recyclable. So is a material that we can recycle again, and we can interchange the product and recreate a new product when we want to shred or recycle our parts. So to validate this material, that is a very beautiful material, we start to design projects and propose to our customer project based on polypropylene material. Next, please. Thanks to the properties of polypropylene, our technology based on WASP 3D printer or robotic arm, we was able to create beautiful and giant structure like this hydroponic system printed in polypropylene. Of course, as you can see, we can afford different degrees. So we do not have our big problem is not the sticking of the first layer. We solve it, but working on a very big scale, we had to develop the system to have a good stability during the printing process. In this case, we was able to print this kind of hydroponic system with wasp in Italy that are like 3 meters tall. And next, please. And we grow also for a bigger scale. So we are able to print structure and architectonic parts or design parts and moreover functional parts. So our goal is not just to prototype a project or try to see if it works, but is to work with the customer dedicated to exposition, retails, and architectural or designer to use our knowledge and create a bigger part using a 3D printer, because we can change literally the boundary of the manufacturing. As you can see, we have in the back of this picture, you can see a large stair chair that is 3D printed. Is a 12-meter stair chair printed in a wireframe system. So we can create geometries that is not possible to create in another material. If you go next. I want to show you this project that we made with external reference and La Macchina. So it's a very challenging project that we did with the 3D printing. Our job is to show the possibility of 3D printing and the material that we can use with the pellet granulating system to create geometry that is not possible to afford in another solution. I don't know, Madeline, if you can put again the video quickly, just to show with the participant that wasn't here during the...
Good. So let me just share it quickly one more time. I should have it. There it is. So just start from the beginning.
Perfect. Now you can keep out the audio if you want.
Oh, it's fine. You can keep it.
Okay, so here you can see our system. We can use polypropylene. In this case, is glass fiber polypropylene, and we developed the system with our robot. We can use this material in a very easy way on a wooden surface, and also with the robot, what we can do is create shapes with bigger overhangs, because we have 6 degrees of freedom, and we are able to create, like in this video that you are seeing like right now, we can create parts that have more than 90 degrees angle without a problem. So again, thank you to 3D Native, thank you to Repsol, of course to IT3D. It's a pleasure to be here. I think that you're in mute, Madeline.
Apologies, thank you. I thought I unmuted myself. Well, with that, we now come to the Q&A. We have quite a few. We will try our best. If people are able, we can maybe stay a couple of minutes afterwards to answer it, but I will start asking the questions anyway. So the first, which people seem to want answered, is from Michael Schmidt, and he asks, how do you optimize the printing temperature with respect to stiffness / impact resistance balance? Not to anyone in particular, if anyone would like to answer. No?
Yes, what we recommend is to print a trial. So we use, in small printers, we use a tower of temperature, so you can see the difference in behavior regarding temperatures and speeds. But when you go through bigger robots and so on, I think you have to try. We can help you and give some recommendations. So what we recommend is to contact us, and we will help you and assist on your starting up. But maybe Gianluca or Tony, if you can add something.
Yeah, I mean, in my case, of course, in large scale, without compact chamber where we can control the temperature in a big space, we did a test. We did test, and depending on the geometry, we had to change a little bit the temperature to increase the stiffness.
Yeah, in our case, we usually don't do any mechanical tests on our materials. We follow the guidelines of the manufacturer, and then we can do comparisons. We can do printing with different temperatures, but we don't really do the mechanical tests.
Good. And then another question is why is printing limited to 35 mm per second?
No, it's not. It's not limited to any speed. In reality, that was just a clue or a trick. If you start with a laptop, it is a starting condition, but you will notice that you can increase the speed as much as your printer allows you to do it. So there is a limit on your printer, but it's not 35. 35 is just a recommendation, but sure, you can go through more speed.
Okay, excellent. Next question, we have quite a few, guys, so get ready. If you shred a product with glass fibers, will the quality of the second print have the same quality as the first time you use the material?
Probably not, but we can recreate a new material. Maybe we can mix, normally when we start, we mix a little bit of virgin material with the shredded one, just to homogenize better and create a material that have more or less the same property of the virgin one.
Well, next question from Roberto this time is, what grain size do you use for the pellets? Actually, there's a few questions in one, so I'll read all of them and you can ask me. Is it the same when the PP is loaded? How do you do the retraction with the extrusion screw? And do you use a special screw when it is PP with fiber? Feel free to answer one of those questions and I'll ask one of them again.
Okay. So about the grind size, we provide this in a regular grind size. So if your extruder is your extruder is prepared to work with granules, it will work well with a standard grind size. Same applies to polypropylene. How do you do the retraction with the extrusion screw? Just optimizing temperature profile and speed. So it's something you have to test and improve in your specific printer. And we will be really help you. So. And if you use a special screw when it's PP with fiber, the answer is yes. You have to use a special screw that resists the abrasion of glass fiber, especially. But it happens with a lot of fibers and mineral fillers. But with PP fiber, not with fibers in general, you have to change your screw and look for one alloy that resists the fiber.
Yeah, similar with most 3D printing processes. So next is, how do you deal with nucleation effect, crystallization speed in the PP induced by different fibers / filaments / pigments?
Yeah, that's a 4 years work to resolve that. So what we did is to design a special to control nucleation and so on. Yeah, it's why we thought that not all the PP you find on the market are good enough to be printed. So it's been 4 years of development to adjust the nucleation and the whole mechanical properties to have a product that will give you a good result when printed.
All right, thank you. Lampros will also like to know if it's possible to have some more info on the food contact approved grades.
Yeah, of course. Except the glass fiber. In our portfolio, the rest of the products are food contact approved, and we give the certification to our customers, so it's no problem. Yeah, need PP, of course, and if there is a special development, because we do developments for customer for a specific projects, and in most cases we can give the food contact approved certificate, so it's no problem there.
Okay, next question is, one of the key properties of Repsol PP is nucleated in the presentation, but it does not affect warpage or shrinkage during printing. Actually, there isn't a question in there, but I assume does it affect warpage or shrinkage during printing?
Yeah, we just design to avoid warpage. So we use nucleating in some products, but they are especially designed to avoid warpage. So we know how to control it, but it's controlled by design, designing a specific products.
Yeah, which makes sense. Michael would like to know, which melt flow ranges do you recommend?
Melt flow ranges depends on the product, and we adjust it to optimize the processability. Or ranges melt flow index go through 10 to 20, depends on the grade, and they are optimized to produce nice processability.
Okay. Here's a question for, I think, all of you, which is, do you need support materials for pellet printing?
Okay, maybe you.
Yeah, I mean, this answer, I think we all can answer this question. So basically, the use of supports will depend on the geometry of the structure that you want to print. You have some, well, it depends also if you are using a robotic arm or if you are using a conventional 3D printer, okay? So in my case, if you are using a conventional 3D printer, a pellet extruder, you will need supports as if you were using filament 3D printing, okay? So if the geometry is complex and there are parts that require support, you will need to use a support. However, you can use polypropylene, but you can use any other materials, because currently in the market we have printers that they have more than one extruder. So you can print with polypropylene, and then you can use another support material for the support. And I think Gianluca now can say something else.
Oh, Gianluca, I can't hear you.
Sorry. When we use a large-scale 3D printer, we can use a support material, but we try to avoid it because then it's difficult to remove. And with the robotic arm, we develop a system to avoid support. So using the 6 axis, we can create complex structure, complex geometry without the support.
Okay, great. And actually a question that I noticed, I think specifically for Gianluca, is, did you use glass fiber reinforced PP for the wall that you showed in the presentation?
Yeah, we use a lot of the glass fiber reinforced PP because it's a very interesting material. It's lightweight, and then what I like of polypropylene is super easy to post-process. So we can give a beautiful finishing of the parts quickly and with a normal tool. Instead, when you use, for example, PLA or PETG, if you try to sand it, it starts to melt. So it's difficult to work in large scale post-processing with those materials. And in case of polypropylene, it's fantastic.
Okay, great. Do you guys have time for a couple more questions? A couple of minutes? Yeah. Okay, we'll try and get the most we can. Actually, if any of you could put an email address as well in the chat so that people who have questions that aren't answered can reach out to you, I'll let you guys do that, but let's just get a couple others. well, one is, could you elaborate on the potential nozzle diameters that are available?
Yeah, of course. So in our case, we typically work with stainless steel nozzles from 0.4 millimeters, then we have 0.6, then we have 0.8, then we have 2 millimeters, we have 4 millimeters, and then we have 5 millimeters, okay? And then we have ceramic parts in order when we are using materials that they are abrasive, or when we are using polypropylenes or materials that they have a high percentage of inorganic material, we highly recommend specialized nozzles, ceramic materials or hardened stainless steel nozzles.
In our case, we use stainless steel nozzles, but of course we work from 3 millimeter nozzle to 15 millimeter nozzle. So it's give us the possibility to move a big flow of material without many problems.
Mm-hmm.
Okay, great. Just to let you know, Eva has provided her email address. We just sent it to everyone. If you have further questions, you can reach out to her. Okay, well, we have a question that I think will be quick, which is, how could you use PP to print using an SLA printer, since this PP is for pellets, not for resin?
No, it's not. For SLA materials, you need to cure your material, and the polypropylene is only for melting technologies. So it includes the extrusion, pellets, or filaments, and also laser sintering, selective laser sintering, because it also melts material, but polypropylene is non-curable material. So in SLA, you can find similar to polypropylene, but they are not really polypropylene structure.
Okay. And actually, I think this is a suitable last question, which is, what would you use for post-processing with PP?
In my case, sandpaper. Sandpaper.
Easy. Okay, well, I think we can wrap it up. There are a few more questions that we haven't been able to get to. I just think some of them are a little long and I don't want to take up all your afternoons. So you can reach out to Eva if you have any questions. She will happily answer.
Of course, yes, really happy to answer. Please contact. Don't hesitate to contact us. My address is in the chat, but you can find me by LinkedIn or with a presentation.
And with that, we will come to the end. So first, thank you so much, panelists, for your insights today. It was very interesting. I hope the audience enjoyed it as much as I did. And well, with that, thank you as well for everyone coming. I will say have a good afternoon, I think, for most of you, since it's officially noon. And be sure to, well, check out Repsol, Lowpoly, and IT3D, and 3D Natives as well. We will let you know when the video is available. Goodbye, everyone.
Thank
Bye.
you very much for your time.
Thank you very much.
Thank you. Bye-bye.
Bye. Have a great day.
You too.